right, so today we're going to talk a little bit about balancing chemical equations. You've already spent some time writing equations. You know reactants and products and arrows and plus signs and those kinds of things. But today what we're going to do is talk about balancing, because at the end of that last handout, I asked you to notice that something was wrong. What was it that you noticed? Hopefully you noticed something like there were more or less atoms on both sides. So sometimes there was like extra atoms that seemed to appear from nowhere, and sometimes there was more than there should have been compared to the other ones, or less than there should have been. Well, the idea here is that that's a problem because of the law of conservation of matter. The law of conservation says that matter cannot be created. You can't suddenly have matter out of nowhere, and you can also not destroy it. You can't suddenly have matter that disappears. So during a chemical reaction, the particles that you start with and the particles that you end with, they have to be the same number of particles. However, they're not going to look the same. They can separate, so we've seen that. They can pull apart. They can combine, meaning that they've bonded together, or they can just change their order of bonding. They can rearrange. So the particles can separate, combine, or rearrange. That tells us what is really happening within the chemical reaction. And so when we balance an equation, we're going to obey this idea of the law of conservation of matter that says you can't lose or gain particles. And so we think of it the fact that matter is made of particles. And those particles can be in different forms, but they're all made of atoms. So what we're looking for when we balance equations is we want to make sure that atoms are not being created or destroyed. There can't be extra atoms on one side or the other side. So atoms can't disappear or appear as we go from one side of the equation to the other side of the equation. When that happens, we say that the equation is not balanced. So balancing is what we're thinking about, saying that it's the same on both sides. That's what we're going to be looking at. So in order to obey the law of conservation, what we're going to do is we're going to have the same number of each kind of atom on both sides. And when I say both sides, what I'm really talking about are the reactants. So how many atoms do we start with on the reactants, and how many atoms do we end up with on the product side? So that's what we're talking about from one side to the other. So you have to have the same number of each kind of atom. Let me fix this. You have to have the same number of each kind of atom on both sides of your reaction equation, and we're thinking about the reactants versus product. So let's think about that last reaction that we wrote in our last notes. We had hydrogen peroxide. We said that it broke down into water vapor and oxygen. So when I look at this, take a look at it. I've got 1, 2 hydrogens, 1, 2 hydrogens. So that's okay. I've got 1, 2 oxygens, but then over here I've got 1, 2, 3 oxygens. So suddenly there's an extra oxygen out of nowhere. Well, let's talk about how we balance it. We're going to work from left to right on the sides of the arrows, and then we'll go back and forth until it's balanced. And then just remember that once you've written the formulas, for example, this has to stay H2O2. If I tried to just remove something to try to make it balanced, like if I just did this, oh, well, look, now it's suddenly balanced. But I've changed my chemistry. Now I'm going from water to water. And O is not a real thing at all. O can't exist by itself. So remember that once you write the formulas, they have to stay as they are. You can only change the number in front, and that's known as the coefficient. So I can put numbers here or here that will multiply back. That's what I mean by you can only change the number in front. Another thing that's going to help is that if one side is odd and the other side is even, you'll find the thing that is odd, double it, and then start over. For example, we said there was 2 hydrogens, 2 hydrogens, 2 oxygens, 1, 2, 3 oxygens over here. So then that's your hint that, oh, this is an odd number. There's an odd number of oxygens on this side. So find the odd, double it. Double means whatever's there times it by 2. So I'm going to put a 2 in front of here. And then I'm going to start over. So if I put a 2 here, that multiplies to everything. Well, now I've got 2 times 2, that's 4 hydrogens. So over here, I need 4 hydrogens. So I'm going to put a 2 in front of there. Now I've got 2 times 2, there's 4 hydrogens, but then 2 times 2, also 4 oxygens. Well, 2 times 1 oxygen plus 2 oxygens, that means I have 4 oxygens. So now this is a balanced equation. Some other hints, keeping water as HOH if you've got an OH or a hydroxide on the other side will help. Keeping group ions together, like count NO3 as one nitrate instead of as separate one nitrogen and three oxygens. And in general, if you can, save H and O until the end. So we'll do a few examples in just a bit. There's just one thing I want to do before we do those examples. I want to make sure you know the difference between a 2 that looks like this and a 2 that looks like this. 2 in front means you have 2 separate NaCl's. It would look like this, an NaCl and another separate NaCl. That's what that means. So you've got 2 Nas and 2 Cl's, but the NaCl is bonded to each other and we've got a separate one. When it looks like this, this means that you have 2 chlorines bonded to 1 Ca. So that looks like this, Ca, chlorine, chlorine, and that's all one thing. So this 2 only goes to the chlorine because of where it's written. Numbers in front multiply backwards to everything. So just seeing the difference there between a 2 here and a 2 here. So up here, remember, the only place we can put numbers is in the front. This formula has to stay as it is. Okay, so with that introduction, I think what's best is let's actually go back and practice it. So these were not written on your note sheet yet, so you can either pause the video right now and write them in, or you can write them in after we do our individual practice. So let's go ahead and start this. We'll go through the order. We start by going from left to right, fixing as needed. 1 Fe, 2 Fe. I've got to fix it. I need more on this side. 2 oxygens, 3 oxygen. Well, there's that even versus odd thing again. This is even, this is odd. Double the part that's odd, so double means times by 2, so I put a 2 there. Now 2 times 3, now it's even. Now there's going to be 6 of those. So over here, okay, well, I can put a 3 in front of that because 3 times 2 is also 6. But remember, you also changed your irons by putting a number here. 2 times 2, that's 4 irons. So this has to go away. But because I put it there, I can change that number and now make it a 4. 4 Fe's, 2 times 2 is 4 Fe's. 3 times 2 is 6 oxygens, 2 times 3, 6 oxygens. This is now a balanced equation. Notice I did not change any of these numbers because I can only put numbers in front once the chemicals are written. All right, let's try this next one. So this next one just has another little piece, but it's the same steps we were doing before. 1 Fe, 1 Fe, nothing to do there. Here I've got 2 of OHs. Over here I've got an OH, but there's only one of them. So I'm gonna put a 2 in front of there to balance that. Oh, but then if I put a 2 in front of here, that makes 2 OHs like I have here, but it also makes 2 H's. So back over here, okay, then I've got to put a 2 in front of here. Now I've got 2 H's. Oh, but if I put a 2 in front of here, that also means 2 I's. But look, I already had 2 I's. So now this is balanced. 1 Fe, 1 Fe. 2 OHs, 2 OHs, 2 H's, 2 H's, 2 I's, 2 I's. That is balanced. All right, let's try the next one. This next one, we're going to just do that like always. Start from left to right. I've got 2 C's here and only 1 here. So I need more on this side, so I put a 2 here. That multiplies there, so now I've got 2 C's on both sides. 2 H's here and 2 H's here, so that looks okay. Oh, but then now I've got 2 HO's here, and I've got 2 times 2, which is 4, plus 1 O right here. Well, there's that even versus odd thing again. So you double the thing that's odd. Well, this is where it's odd. Double and then start over. So I've got 2 times 2. Now I have 4 H's on this side. So back over here, I put a 2. So then now I've got 2 times 2, 4 H's. Oh, but now I've got 2 times 2 carbons also. So I have to change this number. But remember, because I put it there, I can change it. So I need 4 carbons. So 4 carbons, 4 carbons. That's good. I still just have 2 O's right there, but now I've got 4 times 2, so there's really 8 O's right here, plus I have 2, so 2 times 1, I've got 2 O's right there. So really I have 10 O's on this side. So then back over here, I need to put a number here so that blank times 2 equals 10. Well, 5 times 2 equals 10. So now that's going to be a balanced equation. 2 times 2 is 4 C's, 4 times 1 is 4 C's. 2 times 2 is 4 H's, 2 times 2, 4 H's. 5 times 2 is 10 oxygens here. I've got 4 times 2, which is 8, plus 2 over here, so I end up with 10. So then that ends up being a balanced equation. Let's do one more before I send you off to practice on your own. Starting the same process every time, 2 CAs here, only 1 CA there, so I'm going to fix that. I have 1 Si here, silicon, 1 silicon here, so that's good. I've got 2 chlorines here. Over here I've got 2 times 2 chlorines, so that's 4 chlorines, plus I have 4 chlorines right here, so that equals 8 chlorines. Well, over here I had 2, so I need to put a number here, so blank times 2 equals 8. Well, 4 times 2 equals 8. And then I end up with a balanced equation. One other thing that you should check after you've done all of your different practicing is you should double check that all the numbers in front can't be reduced. Like for example, 4, 3, and 2, we can't divide that by something to make them all smaller. 1, 2, 1, 2, we can't divide those to make them any smaller. 2, 5, 4, 2, we can't divide those to make them any smaller. Because whatever you do to one of them, like here there's a 2, a 4, and a 2, those could all be divided by 2, but because there's a 5 there, that can't get any smaller. And these numbers have to stay the same ratio. Same with this one, 1, 4, 2, 1. Well, you might think, oh, these could be reduced. I could divide this by 2 and divide this by 2. But because there's ones here, really the implied ones, we can't make it any smaller. So then those are the correct answers. All right, so now we know some information about balancing equations. And so I'd like you to take some time to go and practice that. But before you do that, let's think about this a little bit. All right, you have an idea about describing and representing chemical reactions to show that the atoms have not been lost or created. And so the idea here is that a chemical reaction means that old bonds have broken and new bonds have formed. So the idea here is that in this previous one, so these bonds broke and then new bonds have formed. But the tricky thing is, well, how do we know that's happening? Well, first I'm going to have you do some balancing practice, and then I'm going to have you do a lab activity that shows you this. How do we know that the bonds have broken? We can't see the bonds break, but the chemical reaction will tell us something else. So right now, go ahead and work on your balancing practice, and then after that, you'll work on a lab activity. Thanks for listening.